This is a preliminary version of this tutorial intended for use until a properly scripted and edited one is completed. Animation Master uses bones and control point weighting and constraints to create rigs so that animators may more easily pose characters for animation purposes. It is always possible in Animation Master to directly manipulate the mesh of a model and keyframe those changes over time for animation effects. But most character animation today is done with rigs that are made of bones that are built into a model. To begin rigging, go to the Objects folder, choose a model, and double-click on it to open it up in a model window. Of course, the mesh of this model was created in modeling mode. To add bones, we need to change to bones mode. Now the mesh of this model is generally locked in place. We won't be able to mess it up or change it by clicking or doing any other operation with the mouse in this window. It just so happens that the first bone I want to create, I want to be exactly in the center of this character. So I'm going to turn on Snap Manipulator to Grid to help me do that. Bones are created with the Add Mode tool that we were introduced to in modeling. I'll click on that, and now when I click and drag in the modeling window, I'm not creating a spline, I'm creating the beginning and end points of a bone. The next bones I'm going to create, I don't need to be exactly on a grid line, so I'm going to turn Snap Manipulator to Grid off. And now I can use the Add Mode button again and start creating a new bone. And I'll start it there and bring it down about to the knee. I'll click on this button again to create another bone. And I'll create yet another bone on the end of that. In Bones mode, we can always use our traditional navigation tools to get a better view of our model. We can always change the position of these bones in this mode by just dragging the endpoints around until they are placed the way we want them to be. Each of these bones has a little structure called a roll handle that helps you control its exact orientation, and that roll handle becomes very important when we later start adding constraints sometimes. So I'm going to make this roll handle point exactly up, and the roll handles on these bones I've put in the leg, I'm going to pull them as far back as I can to make them point exactly backwards. If I look from the top, I can see that this bone handle is pointing exactly backwards. And pointing backwards is not a rule. However, it is generally useful for bones that are part of the same structure, like these two bones that I have put in the leg. It is generally useful for them to all be pointing in the same direction. As the bones are created, they are added to the project workspace underneath the model, and they're given default names of bone and a number. We can give them better names than that. I'm going to call this first bone hip. The next one will be thigh right, and our next bone will be calf right, and the last one will be foot right. And I'm giving them right in their name because they are in the right leg. These bones won't do anything just by being in the model. The artist needs to make decisions about what parts of the mesh to assign to particular bones. To assign mesh to bones, choose a bone, and then choose a selection tool, and draw a selection around the part of the mesh that should go with that particular bone. Now, all of this mesh is assigned to this bone. And while the bone is selected, the control points that are associated with it will flash yellow. And even after the bone is not selected, the control points will retain the color of that bone. I can continue to refine this by doing that selection process over for other bones. I'll select this bone and choose the lasso tool and draw a selection around a portion of the leg. Now this part of the leg is assigned to that bone. And I'll continue on with another bone. Now here it's getting a little bit hard to see the division between where I want the foot to begin and the calf to end. So I'm just going to select a little bit of that there. I've got part of my calf attached to that, but I really need a better view. If I went to a side view, it suddenly becomes much clearer. However, I'm also seeing through to that leg on the other side of the body, and I don't want to accidentally select that. So it's often convenient to hide the part of the mesh that isn't being worked on during this rigging process. So I'm going to go back to modeling mode and then draw a selection around just the half of the model that I want to see. And I'll press H on my keyboard to hide the unselected part. And now I can go back to bones mode, and I have just the half of the model I want to work on right now visible. I'll go back to my side view, and now I'll reselect this calf bone, and I can do my selection over again. To finish off that part, and I'll do the foot in this manner. And now I have these CPs selected, and you'll see again they're showing the color of the bone they're assigned to, and that works in the shaded mode also. If I press 0 on the top of my keyboard to go to shaded mode, the patches take on the color of the bone they are assigned to. The color of these bones has no significance except to help you distinguish one part of the mesh from another, and to help you distinguish which part of the mesh is assigned to a certain bone. If for example, if we had two bones that were too similar in color right next to each other, and we wanted to make that difference more distinct, we could change the color of a bone by selecting it and clicking on this color chip and picking something else, like, for example, how about orange? And there, now it's much more obvious which CPs belong to this bone and which CPs belong to that bone, even when we don't have a bone selected and the CPs aren't flashing. It is useful and advisable to test these control point assignments out as we work on rigging a model. However, we can't actually do it here in the bones mode window, because this window is reserved for editing the position of bones. If we actually move a bone, we'll be changing its final position in the model. We need to be able to test this out some other way. To do that, we need to put the model either in an action or a choreography. I'm going to double click on the actions folder here in the project workspace to create a new action and choose this model I'm working on, and go to a side view. And now I can choose a bone and use the rotate manipulator to test it out and see if the parts of the mesh that I assigned to it are actually moving with it. I can do that with other bones. And yes, so far it appears to be working. These bones are not necessarily independent of each other. There is a hierarchy of parent-child relationships at work here. When I rotate this bone, the calf bone and the foot bone move along with it. However, if I rotate this bone, foot moves along with it, but the thigh bone above it stays put. If I move this bone, everything moves. We can see how this hierarchy is arranged over here in the project workspace. This hip bone is at the top, and all the bones that are indented under it are its children and grandchildren and so forth, and they will move with it when it is rotated or translated or scaled for that matter. This thigh bone is slightly lower, so it doesn't affect the hip bone above it, but it does affect the calf and the foot bone below it in the hierarchy. For the most part, these assignments of control points to bones is working well and looks appropriate, but if we look closely at this ankle, this is looking rather awkward. It would be ideal if we could somehow make this spline ring float between these two bones instead of being directly controlled by one of them, and we can do that. I'm going to go back to the actual model and go to a side view, and then go back to modeling mode, and I'm going to select that spline ring and right click on the selection box and choose Edit CP Weights. And the important thing here is it tells me what bone those CPs are assigned to currently, and I can add a bone that I would like to have influence those control points. That bone happens to be the foot bone. No, it happens to be the calf. It's all right now they are currently assigned to the foot. I want to choose the calf bone, and I'll assign a percentage to that. In this case, it does it automatically because there's only two, but I can type in a specific percentage if I wanted something else. And I'll hit apply and done. And now if I go back to this action, I really need, best practice is to start a new action every time some rigging change is made. So I'll just create a new action, choose the model, go to my side view, and we'll test out this bone. And that is looking better, having that spline ring float between those two bones instead of being directly attached to one. We have a similar situation up here at the knee, where it's very likely that the knee might bend that far in animation, but if we do that same CP weighting maneuver on that particular spline ring, let's go back and try that. I'll select this spline ring, I'll right click on it and do Edit CP Weights, and now I want to add the calf bone to this, and hit apply and done. And I'll create a new action to test this out. That does work. That spline ring is floating halfway between those two bones now, instead of being directly attached to one. But with CP weighting, when a bone has to go through a very large rotation, the spline ring will tend to collapse. That's normal, that's desirable in some circumstances, but in this one, not so much. We really want to use a different strategy for this. If we could attach this spline ring to a bone of its own, it would never collapse. But if we attach it to a bone of its own, it won't be moving halfway between these two bones. Or will it? There is a way we can do that. I'm going to go back to the model and go back to bones mode, and I'm going to add a bone right here at the tip of the thigh bone. And I'm going to pull this rotating handle so it's facing backwards. And that has created a bone here called bone 1. I'm going to rename it knee fan, and I'll tell you in a moment why it's called fan. I also need to make it a child of this thigh bone so it always moves along with it. Right now it's not. Right now it's sitting on its own place in the hierarchy, but I can edit this hierarchy by clicking on this bone in the project workspace and dragging it under the bone I want it to be a child of. And I want it to be a child of thigh. I really ought to make sure I call this knee fan right. So I don't get it confused later. And I can select this bone. When two bones are superimposed, we can select the one we want by clicking on the very end point. And then I'll use my selection tool to assign that middle spline ring to that knee fan bone. And you'll see now they have turned the color of that knee fan right bone. Let's go and test this out in an action. And see what happens. I'll move this calf bone. And, well, we're not much better off than we were before, are we? This knee fan bone is staying put. It is a child of the thigh, and so it will move with it. I could animate it separately and pose it every time I moved this bone, and then repose that knee bone to make it halfway between those two. But there is a way to automate this with something called a constraint. We can use a constraint to make this fan bone, this knee fan bone, always float halfway between how this bone is pointing and how this bone is pointing. There are a lot of different reasons for creating constraints, and so there are different ways of making them. But when we're rigging a character, the best way to add constraints to a character is in something called a pose. I'm going to close out this action to go back to my model window, and I'll right-click in this model window and choose New, Pose, On-Off. And this opens a new window called Relationship, also known as a pose, and adds this in the project workspace underneath the character. I'm going to go to a side view. And I will pick the bone that I want to add a constraint to. Again, when bones are superimposed like they are here, we can pick the one we want by clicking on the endpoint, which is distinct. I'll right-click on this bone and do New Constraint, and I'm going to choose Orient Like. This adds an Orient Like constraint underneath the listing for that bone, which is in this relationship, which is in this character. The cursor turns to an eyedropper, and I can move that eyedropper over the bone I want to target that constraint to. I want it to orient like this calf bone, and so I'll click the eyedropper on that calf bone. And that completes the name here, Orient Like Calf Right. Let's test this out in a new action. And go to a side view. And I will turn this calf bone that fan bone is constrained to, and nothing happens. Why doesn't that work? That doesn't work because poses need to be turned on. There are many uses for poses besides adding constraints to a model, and for that reason they have an on-off switch in case an animator wants to turn a pose on or off during the course of an animation. In this case, because we're adding constraints to a model and we want these constraints to always work, there's a way to turn this, set this on so it's always on when we use the model. I'm going to get up the Properties window and select the model. And there is now something in the model's properties called User Properties, and this pose appears here. Right now it's not set. If I click on this, it's on. I could turn it back off if I wanted to, but I'm going to turn it on. I'm also going to rename it here. Let's give it a more useful name. I'm going to call it Leg Constraints. So in case I make some other constraints that are not about the leg, I could put those in a different pose and give those a meaningful name. Now, let's go back, create an action, go to our side view, and rotate this calf bone. Now, that fan bone is indeed following the calf bone. It is constrained to orient like the calf bone, and indeed it does orient like the calf bone, but again, we've got a bad situation here. It's now following the calf bone completely, and we wanted it to follow halfway. Let's go back to our relationship, and let's select this actual constraint that is listed under the relationship, orient like calf right, and look at its properties in this property window that we still have open. There's an enforcement parameter here, and right now it's set at 100%. Let's set it at 50% and see what happens. And now it floats at exactly halfway between its parent bone and its target bone. I'm turning the calf bone right now, and this knee fan bone always follows automatically halfway in between. And you can see that because this center ring is attached to that knee bone, it doesn't collapse like it did in the CP weighting arrangement that we had for the ankle. The appearance of this arrangement is why this is called a fan bone. There are some times when you might have several of these, each progressively given an enforcement to progressively orient more and more like a target bone, and these would fan out as this bone was extended. And so because of that, the appearance of this kind of use of a fan bone, that's why they're called fan bones. There are some uses of fan bones that have other physical arrangements that don't actually resemble an old-fashioned fan. But this process of making an intermediate bone that is constrained to act somehow between two other bones has come to be called a fan bone, even if it isn't this particular geometric arrangement. So here we have two different ways of dealing with the transition between bones and creating a smooth transition. One was this process of CP weighting a set of control points between two bones, and the other was using a fan bone on which some CPs would ride entirely, and then the fan bone itself would be constrained to behave in some intermediate fashion. This process of moving a chain of bones, as we see here on this leg, and posing them progressively, is called forward kinematics, and this is very common for arms, but this particular arrangement is not very useful for legs. A character that is walking needs to be able to plant a foot firmly on the ground and then move the hips independently of it. If we put this foot touching the ground like so, we can do that, but as soon as we move the hips, that foot comes along. If we were trying to do a person walking, we would want to have some instances where this foot would get planted firmly in the ground and get left behind as the body moved forward. And that is very difficult to do in this forward kinematic arrangement of bones, where the bones are purely a set of parent, child, grandchild, and so on relationships. We need to find a way to make this foot independent of the hips and the leg bones above it. We need to make it not a child anymore. So let's close this action out, and I'll close this relationship. And let's go back to the model. Go to Bones Mode, and go up to these bones in the model under our project workspace. We can edit this hierarchy by dragging this foot to the top of the hierarchy, so it is no longer a child of the hip or anything else. Let's test this out in a new action. And indeed now I can select the hips and move it, and the foot stays put. I can select the foot and move it, and it is possible to move it independently of the hips and the rest of the leg. But obviously there's a problem here. The leg is not following the foot. We can fix that with yet another constraint. Let's go back to our pose that was called leg constraints, and we can call it back up by finding it under the model and double clicking on this relationship 1 listing. That opens that pose window again. Let's go to a side view, and we're going to add a new constraint here. I'm going to select, I want to make this chain of leg bones follow the foot bone. I'm going to pick the end of that chain, which is this calf bone, right click on it, select new constraint, and then select IK kinematic, a kinematic constraint, and then select a target. And that has added this listing to this pose of yet another constraint, this time a constraint on the calf bone. The other constraint was on that knee fan bone. This constraint is on the calf bone. Let's test this out. I'm going to close this old action we have there. And let's create yet another action to test it in. If I move the hips, now the foot is staying put still as we desire. If I move the foot, the hips stay where they are, but the leg follows along. And this is called an IK relationship. We only have to pose this one target, and the rest of it follows along. This is called inverse kinematics. However, it's possible for the computer to find the wrong solution when it's trying to attach that leg. It could actually make that leg bend backwards. And there might be some situations where that would be valuable, but in most human characters, most anthropomorphic characters, we wouldn't want that. We need one more constraint to really make this foolproof. So I'll close out this action, and I'll go back to this relationship. Actually, I will go back to the model. I need to add a target for this leg to always point to. I could add a bone, but this time I'm going to use something slightly different. I'm going to do new, null, and that adds a feature that is kind of like a bone. It has this part that looks like a bone, but it also has these crosshairs that make it a little bit easier to see in some situations. I'm going to move it up here about approximately in front of the thigh. And I'm going to go to the front view and make it, I'm going to nudge it with my cursor key so it's actually in front of that leg instead of right in front of the middle of the character. And I'm going to give it a name. I'm going to give it a name knee target. And of course I want to make sure that it knows it is right. And right now this knee target is child of nothing. I'm going to make it a child of the hip so that it at least travel along with the character. Let's go and test that out briefly. I'll make another action. Go to a side view. Indeed, this null is a child of the hip bone, and so when I move the hip bone, the null moves along with it. It is not a child or affected by the movement of any of these other bones. And we can see that on the hierarchy. It's a child of the hip. It is not a child of any of these other bones. Nor is it a child of this foot bone. We still need to make the leg point toward this knee target. I'm going to close out this action and go back to this relationship. Incidentally, for Macintosh users, this feature of tabbed windows doesn't exist on the Macintosh version. But you can always recall a model or a relationship or an action by double-clicking on it in the project workspace. For example, I can recall this action 1 by double-clicking on it. And I can recall this relationship by double-clicking on it in the project workspace. I'll go to a side view. I want to make the knee point to this target. The knee is sort of on the end of this thigh bone, so I'm going to click the thigh bone and hit New Constraint and select Aim At. And before I pick this null as the target, I'm going to turn off a button that was coming on automatically called the Compensate Mode button. If I left this on, the knee target, the calf bone, would always point toward this null as its target, but it would also always maintain the angle it currently has. So it would be not trying exactly to hit this. That is useful in many circumstances to have that offset, as it's called. But if I turn off compensate mode, it won't try to make an offset. It will try to directly point at this null. So I'm going to select this null as the target. And we see this has moved a little. It's moved as far as it can and still allow the IK constraint that we have on the calf to reach this bone. Let's close this. And let's create a new action. To test this out in. If I move the hips, it appears that the knee does in fact always bend forward to try and reach that target. And if I move the foot, I can't fool it. Now it's always trying to reach that target. And as a side benefit, when we're animating, we can actually pose this null if we want to make knees that bow out or bow in or have to point some direction other than exactly straight forward for some reason. So we've created bones for our model. We've assigned mesh to them. We've CP weighted them and fan boned them and constrained them and targeted them. However, we've only done that on one side. If I unhide the rest of the model, it doesn't have any bones in it. We could go and reproduce all this by hand on the left side, and there are occasions when that is useful. However, Animation Master has some plugins that will help speed this up. Let's go back to Bones mode in our original model. Animation Master has a plugin. If we select a bone and go to Plugins, Wizards, Mirror Bone, it can actually reproduce all the bones on one side over on the other side of the model. However, for this particular one to work, it needs a bone that is parent of everything we want to mirror. And right now, if we look at our model hierarchy, there is no bone that is actually parent of all of this. At the very least, the hip and the foot bone are independent of each other and have no bone as their parent. So I'm going to create one more bone temporarily. Go to a side view, and I'll just use my add tool again and add a bone here temporarily. I'm going to call it root, just to call it something, and then I'm going to drag these other bones under it so that they become children of it. And notice when I drag the hip bone, all of its children went along with it. For just cosmetic purposes, you can reorder these things by dragging them. And now this, I dragged that too far. There. Now the foot bone is child of the root, and so is the hip bone and all of its children child of the root. Now I'm going to go back to a front view. I will choose this root bone. I'll right click, go to Plugins, Wizards, Mirror Bone, and there are a number of parameters for this to deal with situations when things aren't quite perfect. This kind of plugin where we're mirroring something works best on models that really are truly symmetrical across left and right. Our Tom mesh is close to that, and I think this will work. The most important thing is to check which side you are using as the source for your mirroring. X minus is this side over here when we're looking at the front of the model, and so far all of these defaults are pretty much what we want. So I'll hit OK, and Animation Master goes through and creates not only the bones that were on the right side, it recreates them over on the left, but it also recreates the CP weighting. So for example, this spline ring that has that is CP weighted between two bones, that has been recreated over here. And when we select this bone, we can see that the spline ring has not only a flashing dot on it, but a flashing ring to indicate that there is more than one bone involved on this spline ring. We would see the same thing happen if we chose the other bone that's involved. That plugin has recreated these bones and this null. It has named them conveniently left instead of right, so we don't have to go and rename that sort of stuff. It has not recreated the constraints. There's another plugin. We need to do that. This time I will right click in the background and go to Plugins, Wizards, Mirror Constraints. And I'll select the pose that I want to have mirrored and hit OK. And if we go and look at our relationship, we now have, in addition to all those constraints that were on right side things, it has created left side things for all of those. Although I didn't show it when I was screen capturing, I did save my work right before I used those plugins. It is possible to manually undo the work of a plugin, but plugins tend to do a lot. It's usually easier, if the result of a plugin isn't exactly right, to reload a version of the project that was saved right before the plugin was used than to try to manually undo the work of a plugin. A simple Control Z will not undo all the stuff that a plugin can do. We can test this out in yet another action. And we'll take a look at a side view here. And indeed, the hips are independently movable from the feet, and each foot is independently movable from the hips and the other foot. We can test out these knee controls, and indeed they behave properly. Now that we have these working IK legs that enable the whole leg to be posed with just this one bone in the foot, the animator doesn't really need to see these legs that actually make up, or these bones that actually make up the leg. These could be hidden and the animator would be no worse off. So we can go back to the model and back to the model listing in the project workspace and use this eye icon to hide bones that we don't need to see, like the calf bones and the knee fan bones and the thigh bones. Those are all bones that the animator really won't need to touch anymore because their behavior is automatic and governed by the other bones in the rig. And if we look back, now we have a cleaner looking situation for the animator to work with just the bones that he actually needs to manipulate for poses. And of course, if those bones were needed in the future, they could be turned back on. What we've seen here are the essential elements of rigging. We have added bones to a model. We have attached the mesh of that model to appropriate bones. We've used control point weighting and fan bones to smooth the shape of that mesh where joints bend. And we've used constraints to make it possible for the animator to manage a large number of bones with just a few controls. Animation Master has many other powers for creating advanced and effective rigs, but those are the core concepts that show up in almost every character rig that one might need to create. Rigging is an essential part of the 3D animation workflow. And rigging is the essential step between modeling your character and getting on to animating it in Animation Master.